2006, we voted on whether Pluto existed, not whether it was real. It was real. It was right there, orbiting the sun where it had always been, doing exactly what it had always done for 4.5 billion years. We voted on whether it deserved to be called a planet, and by a show of hands, by a committee of 424 astronomers out of the tens of thousands in the world, we decided it did not. We stripped it of its name. We called it a dwarf, a footnote, a piece of debris lost in the dark. And then, 9 years later, we sent a spacecraft to look at it for the first time. And what we found broke us. Not the mountains made of water ice as hard as steel, not the sky that bleeds red snow, not the giant nitrogen glacier shaped like a perfect heart, churning in the dark like a slow poisoned sea. What broke us was what is underneath. Beneath the frozen surface of the most famous dwarf planet in the solar system, in a place so cold that the temperature drops to minus 390 degrees Fahrenheit, there is liquid water. A global ocean. Dark, pressurized, ancient. And the question that has haunted planetary scientists ever since is not whether the ocean exists, it is what might be living in it. To understand why the ocean matters so much, you first have to understand how thoroughly we had written Pluto off. Pluto was discovered in 1930 by a 24-year-old astronomer named Clyde Tombaugh at the Lowell Observatory in Arizona. For 76 years, it was the 9th planet. It was in every textbook. Every solar system mobile hanging from every classroom ceiling had 9 planets, and Pluto was the smallest, outermost, most distant member of the family. Then, in the 1990s and early 2000s, astronomers began discovering other objects in the Kuiper Belt, the frozen outer region of the solar system beyond Neptune, that were almost as large as Pluto. Eris, Makemake, Haumea. Objects that, if Pluto was a planet, should also be planets. The solar system was not going to have 50 planets. So, in 2006, the International Astronomical Union redefined the word planet in a way that excluded Pluto and, with a stroke of bureaucratic precision, demoted it. Here is what nobody said at the time. Nobody said Pluto was boring. Nobody said it was simple. Nobody said it was a dead, featureless ball of ice with nothing to offer science. They just changed its label, and because its label changed, its funding changed, its urgency changed. The New Horizons spacecraft, the probe that would eventually reach Pluto, was proposed, canceled, proposed again, nearly canceled again, and finally launched in 2006, the same year Pluto was demoted. It flew toward a world that humanity had just officially stopped caring about. It took 9.5 years to get there. And when it arrived, in July 2015, it changed everything we thought we knew about what a world in deep space could be. The first image that came back from New Horizons stopped scientists mid-sentence. There, across the equator of Pluto, was a heart. A giant, pale, almost perfectly shaped heart, 1,000 kilometers wide, glowing white against the dark reddish surface of the planet. The internet called it adorable, a cosmic Valentine, proof that even the solar system had a romantic side. Scientists had a different reaction. They called it Sputnik Planitia, and they immediately recognized it as one of the strangest geological features ever observed in the solar system. Sputnik Planitia is a basin almost certainly the remnant of a massive impact that struck Pluto billions of years ago, blasting away the crust and leaving a deep depression across the planet's equatorial region. But that basin did not stay empty. Over billions of years, it filled. Slowly, from the edges inward, volatile ices, nitrogen, methane, carbon monoxide, settled into the basin and froze into a glacier. A glacier 4 kilometers deep in places. A glacier that is not frozen solid, but instead is in slow, constant convection, warmed from below by the trace radioactive heat in Pluto's core, churning in massive cells like a pot of frozen soup on an impossibly slow simmer. The surface of Sputnik Planitia is almost completely devoid of impact craters. On most worlds, craters accumulate over billions of years, a geological record of every collision since the planet formed. But Sputnik Planitia erases them. Any asteroid that strikes the glacier is slowly pulled down into the convecting nitrogen, dragged beneath the surface, and swallowed. The glacier heals itself. It is a surface that consumes its own history. At the edges of this toxic white sea, the nitrogen glacier has pushed and floated massive ranges of water ice mountains, peaks towering 3,500 meters high, as hard as steel in the extreme cold, drifting slowly across the surface like continent-sized icebergs in extreme slow motion. And above all of it, a thin atmosphere of nitrogen and methane transparent blue, when backlit by the distant sun, drifts in slow seasonal cycles, freezing onto the surface in Pluto's winter, and sublimating back into gas when the long 248-year orbit brings Pluto marginally closer to our star. This was not the dead frozen rock we had discarded. This was an active geological world, but the surface was not the revelation. The revelation was what the surface revealed about what lies beneath it. Here is the problem that forced scientists to confront the ocean. Sputnik Planitia, the heart, sits almost exactly on Pluto's equator, and it is enormous. The nitrogen glacier filling the basin is the heaviest single region on Pluto's surface by a significant margin. Basic physics says this should not be possible. Any rotating body, a planet, a moon, a dwarf planet, tends to orient itself so that its heaviest region aligns with its tidal axis. This is called true polar wander, and it operates on geological timescales. The heaviest part migrates toward the equator, facing its tidally locked partner. Pluto is tidally locked to Charon, its largest moon. The face of Pluto that permanently points toward Charon is called the tidal axis, and Sputnik Planitia sits almost perfectly on that axis. This means the heaviest region of Pluto, the nitrogen glacier, migrated to face Charon, which means Pluto rolled over. Billions of years ago, Pluto reoriented itself so that the heaviest thing on its surface ended up pointing at Charon. But here is the problem. Nitrogen ice is not heavy. It is actually relatively light compared to water ice and rock. For Sputnik Planitia to have been the heaviest region of Pluto, heavy enough to drag the entire planet into reorientation, there had to be something massive directly beneath it. Something far denser than the nitrogen glacier on top. The math works out to one answer: liquid water. A subsurface ocean of liquid water, sitting directly beneath Sputnik Planitia, adding its enormous mass to the basin above it, making the combined weight heavy enough to pull Pluto's rotation into alignment. Scientists published this analysis in 2016. It was based entirely on the physics of planetary rotation and the geometry of Sputnik Planitia's position. No one drilled into Pluto. No one sent a probe beneath the surface. The ocean was inferred, solved for, the same way Neptune itself was discovered, by mathematics alone. But how? Pluto is 3.67 billion miles from the Sun. Its surface temperature sits at -390 degrees Fahrenheit. It receives so little solar energy that the concept of solar heating is essentially irrelevant. By every reasonable expectation, Pluto should be frozen solid all the way to its center. It is not. Two mechanisms keep the ocean liquid. First, the pressure of the kilometers of ice above it suppresses the freezing point of water, the same physics that allows ice to melt under the blade of a skate, allowing the skater to glide. The sheer weight of Pluto's frozen crust presses down on the water beneath, preventing it from solidifying. Second, Pluto's rocky core contains trace amounts of radioactive elements, uranium, thorium, potassium, that decay slowly over billions of years, releasing heat. Not much heat, but enough. Enough to maintain a narrow liquid zone between the frozen crust above and the rocky core below. That ocean has probably existed for billions of years. It formed before the first complex life on Earth. It was liquid when the dinosaurs walked. It is liquid right now, at this moment, in complete darkness, under kilometers of ice, 3.67 billion miles away. And it may not be alone. This is the question, the one that changes the stakes of everything. On Earth, life exists wherever three things come together: liquid water, a source of energy, and organic chemistry, the building blocks of biology. Carbon, hydrogen, nitrogen, oxygen, the alphabet of life. Pluto's ocean has liquid water. Pluto's core has radioactive decay, providing a heat source, the same kind of energy that powers hydrothermal vents on Earth's ocean floor. And it is at those vents, in absolute darkness, miles beneath the surface of our ocean, with no connection to sunlight whatsoever, that some of the most complex and ancient ecosystems on Earth exist. Tube worms, chemosynthetic bacteria, shrimp, crabs, an entire food web built not on sunlight but on the chemical energy seeping from the planet's interior. Pluto's ocean likely contains organic molecules. The surface of Pluto is coated in tholins, complex organic compounds formed when ultraviolet light from the sun strikes the methane in Pluto's atmosphere. These tholins rain down onto the surface. Over billions of years, some fraction of them may have been incorporated into the ice and carried down into the ocean. Liquid water, organic chemistry, a heat source. Not proof of life, not even strong evidence of life, but the conditions. The same conditions that, on Earth, produced everything. The scientific community is careful here, deliberately, correctly careful. We do not know that anything lives in Pluto's ocean. We do not have samples. We have not been there. The New Horizons probe flew past Pluto at 31,000 miles per hour and had no instruments capable of detecting subsurface biology, even if it had been orbiting directly above it. But here is what is genuinely unsettling. Before New Horizons, the scientific consensus was that liquid water in the outer solar system was confined to a handful of worlds: Europa, Enceladus, possibly Ganymede, and Titan. Worlds with active geological processes, tidal heating from giant planet gravity, unusual circumstances that could maintain liquid water against the cold. Pluto changed that. Pluto is not tidally heated. It has no giant planet pulling at it. It has only the faint warmth of its own radioactive interior and the physics of pressure suppressing the freezing point of water. If Pluto can have a liquid ocean at the edge of the solar system, with minimal heat, minimal energy, classified as a dwarf planet, then how many other Kuiper Belt objects have liquid oceans? There are hundreds of large Kuiper Belt objects, possibly thousands that we have not yet detected. Each of them is a candidate. Each of them may carry, in permanent darkness beneath kilometers of ice, a dark, warm ocean that has existed for billions of years. The outer solar system may not be a desert of frozen rock. It may be an archipelago of hidden oceans. And if life needs only liquid water, energy, and organic chemistry to begin, then it may have begun, in some form, in many of them. Pluto does not navigate this strange existence alone. Locked in permanent gravitational embrace with Pluto is Charon, a moon so large relative to Pluto that the two do not orbit each other the way a planet and moon normally would. On Earth, our moon orbits us. The moon circles Earth. Earth barely wobbles. Pluto and Charon orbit a point in empty space between them, a shared center of gravity that lies outside the surface of either body. They are, technically, a binary system. Two worlds co-orbiting each other, tidally locked, so that the same face of Pluto always looks at the same face of Charon forever. If you stood on the Charon-facing side of Pluto, Charon would hang in the sky like a massive gray world, unmoving, never rising, never setting. Roughly 7 times larger in the sky than our moon appears from Earth. You could stand and watch it for a lifetime, and it would not move a single degree. And if you walked to the other side of Pluto, the side that permanently faces away from Charon, you would never see Charon at all. It does not exist from that hemisphere. You would only see the dark, star-filled sky. Charon itself carries a scar from Pluto. Its north pole is stained a deep, dark red, a region called Mordor Macula, which sounds like it was named by someone having an extremely good day. This red stain is actually material that escaped from Pluto's tenuous atmosphere, drifted across the 19,640 kilometers of space between the two worlds, and froze onto Charon's cold polar surface. Pluto and Charon share an atmosphere. They breathe together. Two exiled worlds, tidally locked, sharing their chemistry across the void between them in the coldest, darkest, most remote inhabited region of our solar system. We demoted Pluto because it did not meet the definition of a planet. It had not, in the official language of the IAU, cleared the neighborhood around its orbit. That was the criterion. Orbital dominance. Pluto shares the Kuiper belt with hundreds of other objects. It does not gravitationally dominate its region of space the way Earth or Jupiter dominate theirs. So we took its name, but here is what we did not take. We did not take its ocean. We did not take its mountains of floating ice. We did not take its nitrogen glacier that consumes its own history. We did not take its blue sky, which New Horizons photographed as it sped away, a thin, glowing ring of blue surrounding a silhouette of pure black, as beautiful and unexpected as anything we have ever seen in this solar system. We did not take the possibility real, scientifically grounded, not dismissed, that in the permanent darkness beneath its frozen surface, something is alive. Not complex life. Almost certainly not. If life exists in Pluto's ocean, it is almost certainly simple, microbial, ancient, chemosynthetic, surviving at the absolute edge of what biology can tolerate. But simple life is still life. And if simple life can survive in a dark, pressurized ocean beneath kilometers of ice, 3.67 billion miles from the sun, on a world we officially stopped calling a planet, then the universe is not the barren, empty place it looks like from here. Then life is not a miracle. It is a tendency. Something the universe does when given water, energy, and time. And the universe has given those three things to many, many places. Pluto has been in the dark for 4.5 billion years. Its ocean has been liquid for most of that time. It asks nothing from us. It needs no validation. It will be there long after our sun has burned out and our oceans have boiled away and the last trace of human civilization has been erased. In the dark, in the cold, with whatever lives in it. We called it a dwarf. Maybe. But it is asking the biggest question in the history of science. Are we alone? And it has been waiting 4.5 billion years for someone to come and find the answer.